on 9.2, we are going to deal with these rational functions, but there is a catch with it. We are going to deal with quadratics as well, but it just involves factoring. So there's three types of graphs that you can have when it comes to rational functions. The first one we've seen already, where you have just asymptotes. Okay? The second one occurs when you have asymptotes and a point of discontinuity. All right? And what that means is that there's a point on the graph where the graph, bless you, where the graph actually has an empty spot on it. So it's like a line in which one of the coordinates it can't be equal to, and it's an open dot. So that's what the point of discontinuity is. Now, why does that occur? That occurs because we have values on the bottom of fractions that we cannot have them equal to. So you have undefined values. We have values that have restrictions on them. All right? And therefore, you have a hole in your graph. Okay? So determining asymptotes and points of discontinuity. The graph of a rational function may have an asymptote, a point of discontinuity, or both. To establish these important characteristics of a graph, begin by factoring the numerator and denominator fully. So the first example is y equals x plus 4 over x minus 3. Okay?
Are we ever getting a question that, like, the format isn't the same, or is it always going to be x plus something over x?
You'll see right away. Okay? It's all going to work out to be the same thing. Okay? If the numerator and denominator do not have a common factor. Okay? So neither of these they're not a common factor. Now, the factor doesn't mean the numbers have a common factor. It means the terms. Which means you have to have exactly the same on the top as you do on the bottom. X minus 2 over x minus 2. That's a common factor. All right? X plus 3 over x minus 3, not a common factor. The entire term has to be a common factor. So, if you do not have a common factor, the vertical asymptotes are identified by the non-permissible values of the function. For a function that can be rewritten in the form y equals a, x minus h plus k, the k parameter identifies the horizontal asymptote. The vertical asymptote is your non-permissible value on the bottom. Well, let's look at this for example. What is the first non-permissible value, the first restriction you cannot have?
3.
Right, so x cannot equal 3. All right, now, if I quickly do my little x minus 3 plus 3 add 4 and change it into the form I want, so it's over x minus 3, and then this is over x minus 3, I would be left with 1 plus 7 over x minus 3. So that's now in the form that I wanted it, right? Okay. This value right here, this k value, actually defines your horizontal asymptote. Okay? So that's because of the shift. Right. All right? So your k value 1 defines the horizontal asymptote. So if we were to graph this, okay, and let's just focus on our asymptotes. That's all I want to focus on. All right? Because right now I'm telling you that the x value of the asymptote is 3, the y value is 1. Well, what is my h in this question? Plus 3? What's my k? 1. So if my asymptotes are there and there, right? So they're at 0 and 0 right now. Where are they going to move to? Right 3 and up 1. Correct? So what they're saying is that by looking at this right here in the form it is, that value down there gives you the horizontal asymptote. This value here gives you your vertical asymptote. Sorry, backwards. That's your vertical asymptote. because it goes through X. This is your horizontal asymptote because it goes through Y. So then you would move this right 3 and up 1 to there. Okay, so your 0 and 0 moves. Fair enough? Okay, now, this, I need you to look at this again. When you look at the equation, if there is no common factor between the top and bottom, there are just asymptotes for this graph. Okay? The second equation, the second one, deals with at least one common factor. So here's the graph. Y equals x minus 4, x plus 2 over x plus 2. Okay? So the first thing we do is let's find out what our non-permissible is. And what's our non-permissible in this one? X can equal minus 2. All right. So once I've established that x can equal, the x-coordinate of the point of discontinuity is minus 2. So it says here, if the numerator and denominator have at least one common factor, there is at least one point of discontinuity in the graph. And then it says to equate it and then substitute it. But here's what happens. Okay? So you're going to factor this. We've now factored it. So this question could have started off x squared minus 2x minus 8. So that's what I would have started, and then I would have factored it to get to this point. Now that I have it in this point, the first thing you do is find out what the non-permissible value is. Now I'm going to simplify it by canceling it out, and I'm now going to graph what's left. So what's left right here? What is that the graph of? Y equaling x minus 4. What is that the graph of? Is it a parabola? Is it a quadratic? It's linear. It's a line. That's all that's left. So now I just have to graph the line. Same old, what we did in grade 10. Go to 0, negative 4, and go up 1, right 1. And there I have it right there. That's not so difficult, is it? Okay?
Why are you able to cancel off top and bottom?
Or are they not exactly the same? If I divide them, what do I get?
That's right.
Right? Okay. So, but there is a catch to this. There is a catch. I just finished telling you when we started this, there's a point of discontinuity. Okay? So now what I have to do is, I know that the x value is negative 2. So I'm going to substitute negative 2 into that equation. So y equals negative 2, subtract 4. Y is equal to negative 6. So where does the point of discontinuity occur? At minus 2, minus 6. So how do I show that on my graph? I go to minus 2, minus 6, and I draw an open dot. And that shows that there's discontinuity. If I were just to give you x subtract 4, and you graph that line, that would be all there is to it. But because the equation didn't start with just x minus 4, it started with x minus 4 times x plus 2 over x plus 2, we have to take into account that there is a point of discontinuity. Okay? So the first graph I just showed you dealt with just asymptotes. This graph dealt with just a point of discontinuity. So the third one deals with both. So again, same method, both ways to do this. Cody, come back to us yet again. Write this down. Write this down. Maybe you'll pay attention if you're writing it down. Are there any common factors? X plus 2. So that means that we have a point of discontinuity. Okay? At x plus 2. Alright, so first of all, what's the non-permissible values? For me? -2 and 1 also. Okay. Fair enough? So the point of discontinuity, though, occurs at -2. So I cancel those off. Now what am I left with? That. And that's the graph of a rational function. So now I have to do what I learned today so that I can change the form and graph it, right? So let's change this form. So I go x minus 1 plus 1, subtract 4, over x minus 1, right? Equals -3 over x minus 1 add 1. So now I have asymptotes, and I have a point of discontinuity. So now I want to graph that. What's the one thing I added to this graph that we haven't seen yet? What is it? What have we not done yet? What's special about that equation that we haven't done yet? From me? Yeah. It's negative, so we have to flip it over that axis, right? Okay, so that 1 and 1 becomes 1 and -1, and that becomes that, right? So I flipped them. Now I gotta multiply them by 3. So that becomes -1 and 3, which is right here. This one becomes 1 and -3, which is down here. In which way do I move them? Right 1, up 1. So this guy goes right 1 and then up 1 to right there. This guy goes right 1 and up 1 to right here. What happens to my asymptotes? Also right 1 and up 1. So this one goes right 1, up 1 to right there. So there's one asymptote. Here's my other asymptote, right? So I should have, what have I not done so far? I haven't found what? I didn't find my intercepts yet, right? But we're going to leave them for a second. That'll be for tomorrow. What I want to show you is this. Okay, so now I have this graph right here. Okay, but I have a point of discontinuity at -2. So when I put -2 into this equation here, that's going to give me -6 over -3, right? Which is 2. So my point of discontinuity is -2 and 2. So now all I have to do is go to there and put that in. Okay? And that right there is asymptotes and point of discontinuity. So the only way they're going to add to your anxiety level, so to speak, here is they'll put something up here that needs to be factored and something down here that needs to be factored, and that's it. Okay? That's it. So you've got 9-1 and 9-2.